Distributed Control System. Deliverables. The DCS vendor's scope of work includes the following activities: design, program, manufacture, supply, testing, installation, and commissioning of DCS equipment and integration with the existing control system. Programming must align with provided functional specifications. Any deviations must be communicated before implementation. Graphics generation, including all the packages serially connected to the DCS system. Configuration related to sequence of event timestamped points and diagnostic tags for both DCS and related systems. Total system engineering design, including production of a software functional design specification detailing interfaces with existing plant and equipment. Site survey to establish all aspects of the system installation, including existing architecture and capacity. Integrate the DCS to view and seamlessly operate from the new operator station, similar to other operator stations. Interface with the existing system to confirm capacity constraints or the requirement to upgrade any firmware or software for integration. Incorporate preliminary details for power management system. Detailed functional description will be provided as engineering progresses. Installation of specified items in the marshalling cabinet. Factory acceptance testing and report generation, point-to-point integration test at the vendor's works, jointly with system vendors. Testing of typical detectors with related systems. Devices will be free issued to the vendor before FAT. Assistance from device vendors will be provided if required. Point-to-point ASAT for serial-linked equipment. Pre-commissioning assistance. Site survey and report generation with expected site activities. Project management and regular project meetings. Overall responsibility and constant interface with related system vendors to exchange data required for system configuration. Site acceptance testing, commissioning assistance, and ongoing support during startup, including loop checking, troubleshooting, and site modifications, if any. Scope of supply: design, manufacture, supply, installation, testing, and commissioning of DCS equipment as follows. Hardware: fully engineered and assembled weatherproof cabinets including side panels, plinths, anti-vibration strips, etc., as per functional specifications. Fully engineered and assembled marshalling cabinets including isolators, terminal blocks, side panels, plinths, anti-vibration strips, etc., satisfying the functional specifications. Cabinet for mounting maintenance PC complete with connectors. Operator station with standard console, complete with necessary components. Interface cards and modules for system connectivity. Color laser printer with printer cables and associated components. Rack maintenance PC with preloaded software and necessary hardware. Modules and components for signal interface and diagnostics. Upgraded existing printer and necessary hardware for interface. Required system cables for component connectivity. Necessary hardware and software for serial interface. Detailed system test procedures and all necessary test equipment. System documentation as per requirements. Software: configuration software, including display formats, diagnostic software, and complete database and logic as defined in provided documents. Software licenses for operator stations, diagnostic features, and engineering workstations. General: training courses for both operation and maintenance personnel. Operational and commissioning spares. Safe packing and delivery of system components. Vendor responsibility. Vendor responsibility consists of the following as a minimum: design, manufacture, and approval of the equipment and any integral part thereof. Integration with the existing control system based on site surveys. Resolution of any conflicts between requirements and related codes, standards, datasheets, drawings, etc. Delivery of the system with 20% engineered I/O spare for each type of installed module, with reserved space for future expansion. Support of all system hardware and firmware with spare parts and service for the platform's designed life. Providing upgrades and revisions of the software. Ensuring all software licenses are registered to the company. Ensuring the highest possible level of security of operations with redundancy for critical components. Establishing a mutually agreeable schedule at the kickoff meeting with bi-monthly written job progress reports. Project management for system activities during the entire duration of the project. Full responsibility for designing and delivering the sub-supplier's scope of supply and work. indicating any deviations from the specifications clearly for approval. Confirmation of existing system capacity constraints and requirements to upgrade existing firmware or software. Entering into separate service agreements for planned maintenance, spares provision, and specialist services. That design information, provided by purchaser. The following documents will be provided to the vendor for system implementation. Piping and instrument diagrams, typical functional block diagram for closed loops. Packages control descriptions, control system, block diagram, I/O list, various packages serial I/O list, various packages applicable vendors graphics, equipment room layout, layout for graphics generation, cable information, electrical single line diagram for graphics generation, existing functional design specification for reference only. System functional requirements. 1. The system will be microprocessor-based, assembled using standard hardware, software, and firmware, configured to meet specified requirements. All components must be field-proven with successful operation in similar applications for at least 6 months. 2. The new DCS must seamlessly integrate with the existing system through interconnection of the data highway. 3. The DCS will provide centralized control and monitoring of all process operations, including alarm and event monitoring, sequence control, startup, shutdown of individual items of plant, and interface with other control and shutdown systems. All machinery and process packages will be serially linked to the DCS for full control and status monitoring. 4. The system must perform all control and operator process interface tasks, including but not limited to closed-loop control functions, both on-off and regulatory, logic sequence control interlocking of pumps and compressors, logic function blocks with logic gates, display of control loop status including process variable input, controller set points, controller outputs, and controller mode settings, capability for bumpless transfer of controller modes, real-time trend and historical trending of process variables, control of equipment such as motors, pumps, start or stop, lead lag, with manual executive actions requiring double operator confirmation, status display of equipment such as motors, pumps stopped or running, valves open or closed, and active liquid level indication of vessels, color-coded alarms for abnormal or dangerous process conditions, with deviations between monitoring and safeguarding transmitters being alarmed, alarm suppressions and first-out alarms, selection of signals for archive or recording purposes, sequence of event recording and printout for cause analysis, startup and shutdown of individual items of plant and interface with other control and shutdown systems, input signal linearization and characterization, input signal monitoring to generate invalid or out-of-range value status alarms, monitoring and alarming of analog and discrete input signals based on configurable limits. The systems all have at least 3 levels of access: operator, supervisor, and engineer, protected by key lock or password. 5. The system will interface with a GPS clock to configure events and actions chronologically. The GPS clock will synchronize all external interfaces to within 0.01 seconds. 6. It must be possible to modify the DCS configuration online without stopping the processors or affecting existing configurations. Detailed procedures and time required for online configuration should be provided, highlighting any limitations. 7. The operator interface will provide functions including overview displays, group displays, maintenance bypass displays, trend displays, alarm summary displays with horn silence, individual and group acknowledge, and direct access to graphics for points in alarm, status displays for ESD, F&G, electrical breakers, and devices. 8. Controllers must support selectable execution rates with a maximum value of 4 times a second or better, handle I/O devices, power supplies, terminations, and wiring equivalent to 120% of the process I/O counts, and switch over automatically and bumpless on failure of the main controller. The execution rate for fast loops should be a minimum of 0.25 seconds, and for slow loops not exceeding 1 second. 9. DCS I/O processor modules will match the input and output counts listed with an additional 20% margin for fully wired installed spares. 10. The system mass memory will hold all system and application software and database, capable of holding configuration information for future application programming and configuration. 11. I/O modules will provide 24 volts DC power to all field devices from dedicated power supplies installed in the controller cabinets, with power supplies sized for maximum controller I/O loading capacity. 12. All intrinsic safe I/O channels will have galvanic isolators installed and completely wired. 13. The entire power distribution system will be designed to avoid single-cause multiple failures with protective and interrupting devices properly coordinated. Hardware requirement. 1. General. The system must allow card replacement without switching off power or disturbing the process. Short-circuiting of individual inputs and outputs should not affect other inputs and outputs. Theoretical failure rate figures for all boards, power supply units, and other functional subassemblies must be provided. Anti-static precautions, if necessary, should be indicated and grounding wrist straps supplied. The entire system must be RFI immune. 2. DCS system cabinet. Standard cabinets with specified dimensions, including redundant processors, power supplies, communication cards, I/O, and bottom cable entry. Cabinets will have front and rear access with swing frame arrangements and bottom cable entry. All cabinets shall be tagged as per project tagging philosophy, and the cabinet plinth shall be at least 100 mm. 3. Marshalling cabinets. Separate cabinets for AI/AO, DI/IS, AI/DI, NIS, and DO. Cabinets must accommodate all wiring terminations, isolators, serial link terminations, power supplies, and distribution equipment. 4. Cabinet mechanical construction. Cabinets should be Riddle TS series with specified paint finish. Heat extraction fans and dust filters are required for all system cabinets. Cabinets should be designed for bolting together with detachable doors and lockable access. Cable entry should be via bottom-mounted removable gland plates, and removable eye bolts should be fitted for lifting. 5. Operator workstation and printer. An operator workstation is required for all operator interfaces, integrated with the main control room operator stations. Provision for supervisory purposes to obtain current display and process data on an external PC. A common alarm printer must be provided, connected to avoid obstruction to the printing device due to operator station failure. 6. Ventilation. Full heat rise calculations for each cabinet must be provided. Forced ventilation systems, if necessary, should be rated at 100% duty with a twin parallel system. Noise levels for forced ventilation systems should not exceed 50 dBA, with full noise level data provided. 7. Equipment identification. Major components must have stainless steel equipment labels with black lettering screwed to the front face. Internal equipment identification should follow the manufacturer's standard, subject to review. 8. Wiring and terminal requirements. Cabinet wiring must use flame-retardant insulated multi-stranded copper conductors, reduced flame propagation, non-halogenated smoke type. Wiring should be run in low smoke, low halogen plastic trunking, and all connections between system and marshalling cabinets must be via preformed system cables. I/O card allocation should ensure full wiring to connectors and avoid shared cards. Terminals must be Widmelath 2.5 terminals with knife-edge type fuse terminals. AC and DC wiring segregation must be maintained, and all wiring insulation should follow specified color codes. 9. Earthing. Separate earths for instrument screen, clean earth, plant safety, dirty earth, and intrinsic safe earth in each cabinet. All metallic equipment within cabinets must connect to a single common plant safety earth point. 10. Labeling. All cables and wires must be tagged with sleeve-type wire markers. Terminals carrying voltages higher than 48 volts must have removable cover plates labeled for high voltage. Each cabinet and major system components must be clearly labeled with tag numbers, with nameplates in English. 11. I/O requirement. Analog inputs must process specified signals from independently powered or DCS-powered field devices, capable of processing signals from smart transmitters. Discrete inputs must be from volt-free contacts, loop-powered from the DCS, with contact bounce suppression. Analog outputs must generate 4 to 20 mA 24 volts DC outputs, handle smart devices with HART protocol, and be protected from short circuits. Discrete outputs must be loop-powered from the DCS, provided with fused disconnects, and interfaced through interposing relay panels for electrical drives and panels. Software requirement 1. DCS software and displays. The VDU graphic displays must be consistent with existing ones regarding colors, symbols, keystrokes, and methods of access. The DCS must maximize the use of standard proven software, minimizing custom programming. An established method for controlling and validating software development and subsequent modification must be available. All software and associated hardware necessary for programming and modifying system software must be included. Detailed configuration and custom display, building documentation, and technical assistance during configuration activities must be provided. All software must be developed using provided typical functional block diagrams and PNIDs. Standard software. The following software packages must be provided as a minimum: system software, system configuration database, diagnostic software, interfacing software for PLC and external equipment, software for implementing advanced process control strategies if required. System diagnostics. The DCS must use equipment incorporating self-test and fault diagnostic systems. Failure of any component must initiate an alarm at the operator workstation, indicating the type of fault. The diagnostic system must detect faults in the CPU, memory, power supply, I/O cards, I/O points, MCB trips, fuse failures, data link communications, and serial link failures. 4. Alarm event timestamping. The system must automatically detect alarms and events, providing both visual and audio indications at the operator station. Alarm presentation must consider special operating and emergency conditions, with facilities to suppress non-significant alarms. The system must handle various types of alarms, including deviations from normal conditions, system component malfunctions, valve faults, and drive faults. Alarms must be assigned to one of 4 priority levels: high, medium, low, and informational. The DCS must distinguish the order of occurrence of events with an accuracy of 10 milliseconds and capture time-stamped events for analysis. Alarms and events must be transferred through standard function blocks via serial links. 5. Power Management System, PMS. The PMS must be incorporated into the DCS to provide fully integrated power generation and distribution. The system must graphically display the electrical network, monitor and trend power generation inputs, display and record non-process alarms, and perform event recording with 10 milliseconds accuracy. It must allow manual synchronization of generator electrical supplies and implement load shedding if available. Power generation cannot support the load. The DCS must monitor generator output and initiate load shedding based on a pre-configured priority list to prevent system collapse during generator failure. 6. System interfaces. The DCS must interface with existing consoles, cabinets, fire and gas detection systems, compressor unit control systems, power generation systems, package systems, switchgear interfaces, field instrumentation, pump and motor monitoring, telecom systems, and other specified systems. All I/O must be repeated to the DCS via dual redundant serial links with alarm initiation for link faults. The DCS must fully control remote systems with the same functionality as local panels, capable of initiating startup, maintenance overrides, and equipment trips over serial links. 7. Communication bus interface. The new DCS must be compatible with and integrated into the existing dual redundant data highway and DECnet system. Communication buses must have redundant cables routed in separate paths to avoid simultaneous failure with automatic switchover without operator intervention. The DCS must provide system status displays to monitor communication bus operations and generate alarms for bus failures. Detailed DCS grounding requirements and installation details must be provided. The vendor must describe the method used for communication bus error detection and correction, and state transmission speed and communication methods. System interfaces. 1. DCS interfaces. The DCS must interface with existing DCS consoles, existing DCS cabinets nodes, fire and gas detection emergency shutdown system, F&G ESD, compressor unit control system, power generation system, all packaged systems, switchgear interface, all field instrumentation, pump and motor monitoring and control, including vibration systems, telecom system, valve partial close system, multi-phase flow meter, MPFM interface. 2. Serial I/O interfaces. All I/O must be repeated to the DCS via dual redundant serial links, including all ESD, F&G, compressor UCP, power generation, switchboard, and packaged unit I/O with system diagnostic information. The serial communications protocol must conform to the existing system standards, using a specified baud rate and Modbus RTU format. The DCS must fully control all remote systems with the same functionality as local panels, capable of startup, maintenance overrides, and equipment trips over serial links. The following systems must be connected to the DCS through dual redundant serial links: compressor UCP, generator UCPs, chlorination panel, diesel centrifuge package, LV switchboard, HVAC system, ESD F&G system, multiplexer panel, single serial link connection for vibration monitoring systems. Vendor must provide all necessary hardware for interface, while cables must be provided based on vendor specifications. 3. Communication bus interface. The new DCS must be compatible with and integrated into the existing dual redundant data highway. The new operator station must be compatible with the existing network system. Communication buses must have redundant cables routed in separate paths to avoid simultaneous failure, with automatic switchover without operator intervention. The DCS must monitor the operation of all communication buses and generate system alarm messages for bus failures. Failure of both communication bus cables must not disable the DCS control modules. The DCS vendor must provide detailed grounding requirements and installation details, ensuring separation of the system ground from other grounds. Detailed specifications for communication bus error detection and correction, transmission speed, and communication methods must be provided. Communication buses must be supplied by the vendor, and each system cable must be permanently identified and approved by the purchaser. Power supplies 1. General requirements. The DCS must include redundant power supplies sure continuous operation in case of a single power supply failure. Each power supply must be capable of supporting the full load of the DCS independently. The power supplies should be sized to handle the maximum load, considering all connected devices and future expansions. 2. UPS system. An uninterruptible power supply, UPS, system must be provided to ensure continuous power supply to the DCS during power interruptions. The UPS system must have a battery backup capable of maintaining power for a specified duration under full load conditions. The UPS must include automatic switchover features to engage battery power without any interruption to the DCS operation. 3. Power distribution. The power distribution system must be designed to avoid single points of failure, ensuring continuous operation of the DCS. Protective devices must be coordinated to prevent a single electrical fault from causing multiple failures. Power distribution panels should include circuit breakers and surge protection devices to safeguard the DCS components. 4. Power supply monitoring. The DCS must include monitoring features to continuously check the status and health of the power supplies. Alarms must be generated for any power supply faults, including voltage irregularities, overload conditions, and UPS battery status. Power supply status must be integrated into the DCS operator interface for real-time monitoring and diagnostics. 5. Cabling and wiring. All power supply cables and wiring must meet industry standards for safety and performance. Power cables must be routed separately from signal cables to prevent electrical interference. Proper grounding and bonding must be ensured for all power supply components to prevent electrical hazards. 6. Redundancy and reliability. The power supply system must be designed with redundancy to ensure high reliability and availability of the DCS. Redundant power supplies must automatically take over in case of a primary power supply failure without any manual intervention. Regular maintenance and testing procedures must be established to ensure the power supply system remains in optimal condition. 7. Environmental considerations. Power supply components must be designed to operate within the specified environmental conditions, including temperature and humidity ranges. Cooling and ventilation systems must be provided to prevent overheating of power supply units. The power supply system must be protected against environmental factors such as dust, moisture, and corrosive elements. By following these requirements, The power supply system for the distributed control system will ensure reliable and continuous operation, safeguarding against power interruptions and electrical faults. Design and performance criteria. 1. General design requirements. The DCS design must ensure high reliability, availability, and maintainability. The system must support online modifications without interrupting operations. All components must be field-proven with successful operation in similar applications for a minimum period. 2. Redundancy and fault tolerance. Redundant controllers, power supplies, communication buses, and I/O modules must be provided to ensure system reliability. Redundant components must automatically take over in case of primary component failure without operator intervention. The system must be designed to continue operation without degradation in performance upon single component failure. 3. Scalability and expandability. The DCS must be scalable to accommodate future expansions without significant changes to the existing setup. Provision must be made for additional I/O points and processing capacity to handle future requirements. The system must allow easy integration of new components and subsystems. 4. Performance requirements. The system must support fast execution rates for control loops with a minimum execution rate for fast loops and an adjustable rate for other loops. Controllers must handle the specified number of I/O points and processing tasks efficiently. The system must provide real-time and historical data trending with high-resolution data storage capabilities. 5. User interface and usability. The operator interface must provide clear, intuitive, and user-friendly displays for monitoring and control. The interface must include overview displays, group displays, trend displays, alarm summaries, and status displays for all connected systems. The system must support multiple levels of user access with appropriate security measures. 6. Alarm and event management. The DCS must have comprehensive alarm and event management capabilities, with priority levels for alarms. The system must support alarm suppression, first-out alarms, and event recording with time stamping. Alarm and event data must be easily accessible for analysis and troubleshooting. 7. System diagnostics and maintenance. The DCS must include self-test and fault diagnostic features for all major components. Diagnostic information must be accessible through the operator interface, with alarms for detected faults. The system must support preventive maintenance schedules and provide alerts for required maintenance actions. 8. Environmental and safety considerations. The system must be designed to operate under specified environmental conditions, including temperature, humidity, and exposure to corrosive elements. Safety measures must be incorporated to protect against electrical faults, power surges, and other hazards. All system components must comply with relevant industry standards and regulations for safety and performance. 9. Documentation and training. Comprehensive documentation must be provided for all aspects of the DCS, including design, installation, operation, and maintenance. Detailed manuals, wiring diagrams, and system schematics must be included. Training programs must be available for operators, maintenance personnel, and engineers to ensure proper system use and upkeep. 10. Compliance and standards. The DCS must comply with all relevant industry standards, codes, and regulations. The system design and components must meet specified quality and performance standards. Compliance with regulatory requirements for safety, environmental protection, and operational efficiency must be ensured. By adhering to these design and performance criteria, the distributed control system will provide robust, reliable, and efficient control for the specified applications, ensuring seamless integration, high performance, and ease of use. Project Execution Plan. 1. Project Management. A dedicated project manager must be assigned to oversee all activities, serving as the primary contact for all official communications. Regular project meetings must be held to review progress, address issues, and plan upcoming activities. A detailed project schedule must be established at the kickoff meeting, outlining all target dates for document transmission and equipment delivery. 2. Documentation and reporting. Bi-monthly written job progress reports must be issued to the purchasing department detailing the current status of the project. All project documents, including design specifications, drawings, and reports, must be prepared and submitted according to the agreed schedule. Any deviations from the project schedule must be approved by the purchaser. 3. Design and engineering. The design phase must include site surveys to gather necessary information for system integration. Detailed engineering must cover all aspects of the system, including hardware, software, and interface requirements. The DCS vendor must ensure the design meets all specified functional and performance requirements. 4. Procurement and manufacturing. All equipment and components must be procured and manufactured according to the approved design specifications. Quality control measures must be in place to ensure all items meet the required standards. Equipment must be tested and inspected before delivery to ensure compliance with specifications. 5. Installation and integration. Installation of the DCS equipment must be planned and executed to minimize disruption to existing operations. Integration with existing systems must be seamless, with thorough testing to verify functionality. The vendor must coordinate closely with other system vendors to ensure smooth data exchange and compatibility. 6. Testing and commissioning. Factory acceptance testing (FAT) must be conducted to validate the system's performance before delivery. Site acceptance testing (SAT) must be performed after installation to ensure the system functions correctly in the operational environment. Commissioning assistance must be provided to support the initial startup and address any issues that arise. 7. Training and support. Comprehensive training programs must be provided for operators, maintenance personnel, and engineers. Training must cover system operation, maintenance procedures, and troubleshooting techniques. Ongoing support must be available during the startup phase and for a specified period afterward to ensure smooth operation. 8. Warranty and maintenance. The DCS vendor must provide a warranty covering the system components and performance for a specified period. A maintenance plan must be established, including scheduled inspections, preventive maintenance, and access to spare parts. Support agreements must be in place for the timely provision of specialist services and replacement parts. 9. Compliance and quality assurance. All project activities must comply with relevant industry standards, codes, and regulatory requirements. Quality assurance processes must be implemented to ensure all deliverables meet the specified requirements. Any conflicts or issues must be promptly addressed and resolved in consultation with the purchaser. By following this project execution plan, the successful implementation of the distributed control system will be ensured, delivering a reliable and efficient control solution that meets all specified requirements. 1. General documentation requirements. Comprehensive documentation must be provided for all aspects of the distributed control system, covering design, installation, operation, and maintenance. All documents must be clear, accurate, and detailed, ensuring that end users can effectively understand and utilize the system. 2. Design documentation. Detailed design documents must be provided, including system architecture, hardware specifications, and software configuration. Functional specifications outlining the system's capabilities, performance criteria, and interface requirements must be included. Wiring diagrams and system schematics must be provided to illustrate the configuration and connectivity of all components. 3. Installation and configuration documentation. Step-by-step installation guides must be provided to ensure proper setup of the system hardware and software. Configuration manuals detailing the setup and customization of the DCS must be included, covering all user configurable parameters. Procedures for integrating the DCS with existing systems and equipment must be documented, ensuring seamless integration and compatibility. 4. Operation manuals. User manuals must be provided for system operators, covering all operational aspects of the DCS. Detailed instructions on how to use the operator interface, monitor system performance, and respond to alarms must be included. Manuals must also cover routine operational tasks, such as starting and stopping the system, adjusting control parameters, and generating reports. Maintenance manuals. Comprehensive maintenance manuals must be provided, detailing routine maintenance tasks, troubleshooting procedures, and repair instructions. Maintenance schedules outlining the frequency and scope of preventive maintenance activities must be included. Detailed procedures for diagnosing and resolving system faults, replacing components, and performing system updates must be provided. 6. Training materials must be provided to support the training programs for operators, maintenance personnel, and engineers. Training manuals must cover system operation, maintenance procedures, troubleshooting techniques, and best practices. Documentation must include practical exercises and scenarios to help users develop hands-on experience with the system. 7. Testing and validation documentation. Test plans and procedures for factory acceptance testing, FAT and site acceptance testing, must be provided. Test reports documenting the results of all testing activities, including performance tests, integration tests, and validation tests, must be included. Procedures for verifying system functionality, performance, and compliance with specifications must be detailed. 8. Change management documentation. Procedures for managing changes to the system configuration, software, and hardware must be documented. Change request forms, approval workflows, and version control mechanisms must be included to ensure systematic and controlled changes. Documentation must cover the process for tracking and implementing updates, upgrades, and modifications to the system. 9. Compliance and certification documentation. All relevant compliance and certification documents must be provided, demonstrating that the DCS meets applicable industry standards and regulatory requirements. Certificates of compliance, test certificates, and inspection reports must be included. Documentation must also cover any specific safety and environmental standards that the system adheres to. 10. Document control and management. A document control system must be established to manage the creation, review, approval, distribution, and revision of all project documents. Procedures for document identification, storage, retrieval, and archiving must be documented. Responsibilities for document management tasks must be clearly defined, ensuring accountability and traceability. By adhering to these documentation requirements, the distributed control system will be thoroughly supported with clear and comprehensive information, facilitating proper installation, operation, maintenance, and management.